Okay, so now that we have a proper game board set up, it's time to set up our player controls. Now the player in this case is our sphere, and our player needs to be a solid object that's able to collide and interact with other objects in the scene. In order to enable this, we have to add a rigid body component to the player object. So we're going to go over to, with the player selected, we're going to go over to the inspector, look at the properties of the player, and we're going to add a component. And that component, let me drag the window down here so you can see the menu, and we'll go to physics, and we're going to select rigid body. Now, adding a rigid body to our player or any of our other game components will allow its motion to be under the control of Unity's physics engine. Adding a rigid body to our player or any of our other game objects puts its motion under the control of the Unity physics engine. This means it will be pulled downward by gravity and it'll react to collisions with other objects. The rigid body component also allows you to apply forces to an object to control it and move it around. And it also allows scripting so that you can make those movements look physically realistic. And as we look at our rigid body component, note that use gravity is checked. So if I yank this sphere up and then I hit play and I look down into my game window, you can see that gravity pulled my player sphere down right on top of the game board. So then I can just unclick play and hit Control Z to put the sphere back where I had it. So now in order to apply forces and control our player, we need a script. So if I go down into the project window, I'm going to create a new folder and I'm going to call it scripts. And then with the scripts folder selected, I'm going to create a new C# script. And I'm going to call that one player controller. And since I'm going to use this script to control the player, I'm going to drag it right onto my player object. And if I select the player in the hierarchy view, I can scroll down and I can see that the C# script has been added to it. Now I want to open the C# script and edit it. So what I'm going to do is double click it. Double-clicking a script in Unity opens up a program called Monodevelop. Monodevelop is an IDE just like IntelliJ that's designed specifically to edit Unity scripts. And every standard C# script is going to come with the class name that's part of the MonoBehavior class, and then it's going to come with the start and update methods. Start is the initialization method. So everything in start runs as the program loads. Update is recalculated, or it's called and recalculated once per frame. So every single frame that moves forward in your game, you're going to run update. So the first thing we're going to do in this class is create an instance variable to hold the place of our rigid body object. So we're going to say, we're going to make this a private instance variable, and it's a rigid body reference, and we'll just call it RB for rigid body. Then inside the start menu, or inside the start method, we're going to set RB equal to a get component. So this is a method that will retrieve information from components in our actual game. So now we've created this rigid body variable in our script that holds the value of the rigid body from get component. Now if we only reference get component and don't reference it in any other way, it assumes that we're getting the rigid body component from the object that our script was attached to, in which case our script is attached to the player object. So it's saying get that rigid body component from the player sphere, and we'll put it in this variable called RB so we can reference it later. Now we're going to work on update. So these are going to be the things that we're going to want to run once per frame. We're going to create two variables here called floats. And float is just a decimal number. So we're going to create a float or a decimal number, and we're going to call it move horizontal. And that's going to hold a numerical value for our horizontal movement. And we're going to do the same thing with our vertical movement. We'll create a float for it, and we'll call it move vertical. And that's going to be the variable that holds a numerical value for our vertical movement. And to calculate the values for these, we're going to use a method called input.getAxis. And for the horizontal, we're going to use the parameter horizontal. And for vertical, we're going to use the parameter vertical. So before we go any further, we need to understand input.getAxis. So input is a class in the Unity API that reads the axes from various different types of input. And then the input.getAxis method analyzes the input from various different types of input from the system. In this case, we're using either the arrow keys or the AWSD keys. And so it analyzes that input and it returns a decimal value that corresponds to the movement that we're invoking with those buttons. So for example, if I press the W, that means I'm moving up, and that will register with input.getAxis vertical, and it will return a positive number as I'm going up. But if I press the S key or the down arrow, the same method, the vertical, knows that I'm moving negatively vertically, so it will record a negative number. So that returns negative if I'm going down, positive if I'm going up. And horizontal is the exact opposite. If I use left or right keys, or D or A keys, if I'm moving to the right, meaning I'm pressing down D or pressing the right arrow, that's going to return a positive number. But if I'm pressing the A key or pressing the left arrow and moving left, it's going to record a negative number, or rather return a negative number. So now that we have these methods to analyze and calculate our horizontal and vertical movement, we need to add those to a vector 3. So we're going to create a new vector 3 object called movement. The vectors 3 class passes our 3D positioning information back and forth between objects. It takes an X parameter for left and right, a Y parameter for up and down, and a Z parameter for forward and back. We're only going to be using X and Z on this game board since we're only going to be moving forward and back and left and right. So we're going to set this vector 3 movement equal to a new vector 3 object, and we're going to feed it the parameters move horizontal and move vertical, and in the middle here for the Y we're going to use 0.0f since we're not using that one. So now that we have this vector 3 called movement that carries all of our positioning information, we're going to add that to a force that we add to our rigid body object. So remember that our rigid body objects allows us to apply forces to our player object to move it around. So we're going to take our rigid body object, RB, and we're going to use the add force method to apply a force to the rigid body on our player, and we're going to give it the vector movement to control the direction and velocity in which we apply the force. And vector 3 is going to control that. So just to recap what we've done so far, we're creating a private instance variable to hold our rigid body information. We're setting it to equal to the rigid body component that is on our player object. Then we're setting up two float variables to hold the values of our inputs for left and right and up and down, or for left and right and forward and back. And then we're adding those to a vector 3 that's going to control the force that we apply to move our player sphere around. So once you understand that, go ahead and hit Control S to save that. If you go back into the Unity editor, we should be able to click play here and move our rolly ball around. But you can see how awkward that is and hard to move, and it's just not very responsive. So we need to make a change. Make sure you press play again to stop the game and go back into Monodevelop. We're going to add one more property here, and we're going to add what's called a public instance variable, and it's going to be a float, and we're going to set that to speed. So we're creating this new float variable called speed, and that's going to control the velocity of our movement. And all we have to do is multiply that movement, the movement that we're adding to the force of our rigid body, by speed. And speed can take on any value that we want. And the cool thing here, and what's going to make this super useful, is when you add a public variable or a public instance variable in Monodevelop or in your script, if you save that and go back into Unity and we click on our player object, we can go down to this script and you can see that we have an adjustable value here for speed. So we can actually adjust this right in the editor, so we can double check and make sure it works. So I can hit 2 here, and that changes that speed variable that I'm using here, that I'm multiplying my movement by, right inside the editor. So if I hit play again, I want to double that speed just to start off with, because that was super slow. So you can see if I move this around, it is kind of twice as fast, but it's still super slow. So I'm even going to bump that up to maybe, let's go with 6. And we'll click play again. And you can see that's just about perfect for what I want to do. So if you look down in the game window, you can see that that's working pretty good. So I got that all set up. So now that we have our player movement all set up, on the next video, I'm going to show you how to set up your camera.